Hello friends and welcome to Architects Academy Virtual Classroom. Today's lecture is going to be about water-cement ratio. This can be a question in your exam, like write a short note on water-cement ratio. So you can take down notes while viewing this lecture and prepare for your exam. Now the first point which we are going to see is why is water required in concrete? So you are very well aware that water is a very vital ingredient in concrete. Without water, we cannot produce concrete. So basically water is required in concrete for two reasons. The first reason is that it is required for causing the chemical reaction which is called as the hydration reaction. So water reacts with cement and causes the cement to harden and to gain the strength. The second reason is that it is required for easy flow of concrete into the formwork. Means that the concrete should flow into the molds which are made, which are called as the formwork, and this is termed as the workability of concrete. Now the question is how much water is required in concrete. We have seen that the proportion of concrete 1:4:8, 1:3:6 talks about how much cement, sand, aggregate has to be there in concrete, but it never talks about how much water is to be added to the mix. So this is actually defined by a separate ratio called as a water cement ratio. So the amount of water to be added in concrete is defined by the water cement ratio. So the water cement ratio can be defined as the ratio of the weight of water divided by the weight of cement in the concrete mix. So putting it in the form of an equation, what we'll see is that water cement ratio is equal to amount of water by weight divided by the amount of cement by weight. So now let us take an example and see how much water is required to produce M20 concrete. So let us calculate the amount of water required for producing M20 concrete. For this, the water cement ratio has to be maintained at 0.6. This value is given in the IS code, and therefore we'll be now substituting this value in the equation which we have seen. So the water cement ratio is equal to water in kilograms divided by the cement in kilograms, which we normally take as 1 bag of cement. Now you know that 1 bag of cement weighs 50 kilograms. So substituting the values in this equation, what we'll see is that to have a water cement ratio of 0.6, we'll see that 0.6 is equal to water in kilograms divided by 50 kg, which is the weight of 1 bag of cement. Now cross multiplying these values, we'll see that water in kg is equal to 50 multiplied by 0.6, that is equal to 30 kg. Now we don't measure water in kilograms, but we know that the density of water is 1, and therefore 30 kilograms of water is equal to 30 liters of water. So in conclusion, what we can say is that to produce M20 concrete while maintaining a water cement ratio of 0.6, we have to add 30 liters of water to the mix. Now let us see a table which gives the relationship between the concrete proportion, the water cement ratio, and the strength of concrete. So what we are seeing here is the different columns. In the first column we are seeing the grade of concrete, which is M5 to M20. In the next column we are seeing the proportion of the different ingredients. In the third column we are seeing what is the water cement ratio that needs to be maintained as per the IS code. And in the fourth column we are going to see the amount of water in liters as per the formula which we have discussed in the earlier slide. So you already know what is meant by grade of concrete. The number 5, 7.5, 10, 15, 20 indicates the compressive strength of concrete in newtons per millimeter square after 28 days after casting the concrete. So to produce M5 concrete, you need to have a proportion which is 1:5:10, which means 1 part of cement, 5 parts of sand, and 10 parts of coarse aggregate. You need to maintain a water cement ratio of 1.5. So when we multiply this water cement ratio by the weight of one bag of cement, that is 50 kg, we get the amount of water required in liters, that is 60 liters. The same is true for all other grades of concrete. We have already seen this for M20 concrete in the example, that to maintain a water cement ratio of 0.6, which is required for M20 concrete, if we multiply 0.6 by 50 kg, which is the weight of bag of cement, we will get the water in liters as 30 liters. So this is the method of actually finding out how much water is going to be required for different grades of concrete or different strengths of concrete. Now there is a sort of a paradox of water present in the concrete. So what is that paradox? If we have less water in concrete, then what happens is that the concrete can be termed as a dry mix. Now the dry mix cannot easily flow into the formwork and can cause honeycombing. This means that it has got a lower workability. But because the water is less, or it is say optimum, we can get a greater strength of concrete. If we go on increasing the water in the mix, the strength of the concrete will go on reducing. Now if we add too much water, or if the amount of water is more in concrete, what happens is that we get a wet mix which can easily flow into the formwork, which would mean that it is highly workable, that is, it has got high workability. But as we discussed earlier, the strength of the concrete goes on reducing as we add more and more water to it. This can be seen from the graph shown below. So in this graph, what we see is on the y-y axis, we have plotted the strength of concrete, and on the x-x axis, we are having the water cement ratio. So if you look at this graph, you will see that for optimum water cement ratio, the concrete has achieved its greatest strength. If we go on increasing the water cement ratio, which means that if we go on adding more water to the concrete, the strength of the concrete will go on reducing slowly. So therefore, adding more water to concrete is not the solution for getting workability. So this is the paradox, that how do we achieve the greater strength but at the same time maintain the workability of the concrete. So to overcome this problem, the solution is to use an admixture called as a superplasticizer. So this superplasticizer is nothing but a chemical which is added to the concrete, which gives it certain properties. So what are the properties which are given by the superplasticizer? So the superplasticizer acts as a lubricant and improves the workability of concrete, which means that it allows the concrete to flow very easily into the formwork and surround the reinforcement properly. Second thing is, because of this, we can maintain a water cement ratio which will be as per the optimum amount of water required in the concrete. Another property of the superplasticizer is that it acts like a catalyst, means that it does not react with the concrete and therefore it does not harm the concrete in any way. So this is what we learn about water cement ratio. I hope this video was useful to you. If you have liked our video, please give us a like and also share the video with friends. Please subscribe to our channel to get more videos. Press the bell icon to get notified about new videos. If you have any questions, write to us at architectsacademy@gmail.com. Thank you.